Good evening, everyone. My name is Minjan. This is a seminar for Introduction to Artificial Intelligence. This is the last seminar before we start the fall semester. Today, the topic, Introduction to Artificial Intelligence. So this is a very big, broad topic. We're not going to talk about the big umbrella, the big project. Rather, this is a seminar for the class that we're going to offer at Momentum, specifically designed for students in middle school and for high school students. Hopefully, after today's seminar, you can have a better understanding or idea of this class that we're going to offer in the fall semester and also in the spring semester. This class, Introduction to AI, we would start from the history of AI for many students and also for many parents. If you're not familiar or not in the field of AI, so let's have some maybe introductory lesson for the history. Of course, for many students, right, if you spend maybe a couple of hours, you could get this information from, say, just ask ChatGPT and say, okay, what is the history of AI? Probably you're going to get some information like this. Anyway, so here is what I would describe or classify the stages of artificial intelligence since the introduction of modern computers. The birth of AI, that's in the 1950s, right after the emergence of electronic computers. So in the 1950s, mathematicians and computer scientists actually realized we could do something to build intelligence to machines or to the computers. Actually, people had written computer programs to play checkers, the game, the board game. Actually, it was pretty good. Actually, could beat pretty good players, human players. Remember, that's in the 1950s. And computers were still very slow compared to the power of computers today. But still, it was rather amazing. And also in the 1950s, people had thought about to have the machine intelligence that could prove mathematical theorems. So that's called the theorists with the logic. Of course, we're not going to talk about logic in this class, but in the 1950s, logic, especially the first order logic, was already available. So people used the logic and reasoning to build the system that could prove quite many math theorems. And actually, some of them, the proof was even better than humans. And then based on the discovery and also the progress, people were so optimistic. So actually, some were even claiming machines with intelligence would come very soon, not say 20 years, 30 years, 50 years. So that led to the first movement of artificial intelligence. But of course, that failed. People realized we could not have that intelligence that we hoped to exhibit from machines, from computers. When I say machine, right, that's computers. So that came the first winter of AI. And then in the 1980s, the expert systems became popular. So what is this? People thought, okay, we cannot solve general purpose or common sense problems, but we can solve a specific question. So people would ask experts in the field to build rules and use logic to build the expert systems. So in this period of time, the neural network idea came up. Still did not came the fruit of AI that we have seen today, like you have seen in ChatGPT. Still very naive, but still people made a lot of progress. actually, some of them would lead to the construction of Deep Blue. But in the 80s, right, people did not expect that we would have breakthrough. And then come into the 21st century, another type of ideas came to be popular. That's intelligent agents. This is, in a simple term, that we have the decision theory that will be combined with the huge improvement for computer powers. So when I say the power, that includes the speed and also the memory capacity. Due to the Moore's law, many of us heard about this one in computer hardware. About every 18 months to 2 years, the speed of computers, particularly the CPU, the central processing unit, would double its speed. So after about 50 years of progress here, the computers would be about 10 million times faster than the computers in the 1950s. So as I said, right, the combination of the what we call the intelligent agents. So it can make decisions by observing the environment and take actions so that it can maximize the chance of success. And in this period, actually, a lot of progress were reported. The most famous one probably would be the Deep Blue beating the most talented human players. Actually, that's in 1997. Deep Blue beat Garry Kasparov in chess. Chess was considered to be a very complicated game. Okay, that's still for the games, not for common sense problems. But that unknown actually inspired many people in the research and also in application. And also in 2005 and 2007, actually, the self-driving had some success. The self-driving cars actually went to the road. Actually, one of them is 2005. Actually, was in desert. Of course, there's no human, so you don't worry about accident involving the human. And then so also 2007, self-driving cars actually were in the street, even though not very long distance, about 50 miles, without accident. Actually, the cars actually will follow the traffic laws. So that actually was very exciting. Remember, that's in 21st century. And then from the last decade, from 2010, 2011 till now, that's what I would refer to the deep learning stage, the fourth stage of AI. I would call this one deep learning. So this one is characterized by big systems that has the high levels of abstraction, and also people would apply the multiple layers of processing. And people realized or have witnessed, actually even for students, right? Just several years ago, Siri could answer some simple questions. That's common sense questions, not just say, how to do, say, arithmetic, right? How to play, say, simple games, but could answer some simple questions in real life, but still not impressive until a year or two, the ChatGPT and also the Bard, right, came to operation. People can see the results, the progress. We did have a seminar last semester talking about ChatGPT. That is one example of deep learning and also reinforcement learning. With this, actually, people realized now it is the era or the time for artificial intelligence. So even though we had in the past half century of development, now we begin to see the progress that can be applied to real life tasks or problems. Actually, now, even though you don't use ChatGPT, the most recent version, unless you have the paid version, right? But if you use the Bing, the Microsoft search engine, it actually does use the most recent version of ChatGPT. Should be version 4. Okay, so here is just a simple history of artificial intelligence. For this class, of course, we're not going to talk about the most recent one. Rather, we're going to focus on maybe the simple ones. Remember, right, this one is designed specifically for students in middle school and high school. Okay, so in general, if you have a class in AI, these are the topics that possibly would emerge. If you check the curriculum in many universities and colleges, they could include these topics here. Machine learning, I know you would say, okay, machine learning is probably more advanced. Actually, it can have different meaning. For example, machine learning now would have, as I mentioned, right, like the ChatGPT generative, the pre-processed transformer that will have a lot of the up-to-date research techniques. So you're not going to start that. But machine learning can also be described as simple, like say linear regression. Right? Many of us have learned or have used linear regression. So you're given a bunch of points and try to approximate the data using a line and use this line to make prediction. This is an example of machine learning. Okay, so we can apply simple machine learning ideas. And of course, we can also make it more up-to-date, the most recent techniques in machine learning that would be much more complicated. Again, we're not going to do that. Rather, we're going to focus on these two topics in this class, that is search and also in game playing. Game playing was, as I mentioned, right, in early days, that's the main focus or the centerpiece for artificial intelligence. Okay, what does it mean by search? So just use the chess example. At each player's turn, right, there are multiple options. A player can have maybe 10, maybe 20 options to make a move. So once player 1 makes a move, right, then the player 2 can also make a move. Again, player 2 has maybe 10, maybe 20 choices. And again, when it's player 1's turn, right, again, it has, player 1 has a lot of choices. So if you have this choice after choice after choice, if you do a simple estimate, the search space, that means, right, all the possibilities, the search space would be huge. That is actually what we call the complexity. If it's behave like human being, right? Okay, I'll make my move, and for this one, and I'll predict, right, what my opponent will move. After my opponent's move, right, what would I react? After I make the third move, right, how would my opponent react? So if you can plan, say maybe 3 steps or 4 steps, that's actually quite advanced. Of course, the best human player, right, like Garry Kasparov, it was said, right, he could see maybe 15 steps ahead. That means whenever he makes move, he has thought about after 15 steps, what will be the case? So if you choose the best move, so that's a lot of thinking. Remember, right? For computers, we don't have, the intelligence yet. So if you just say, okay, for each move, right, there are 10 choices. So the first move you have 10, the next move, right, you have 10 times 10. The next time you have 10 times 10 times 10. So this will experience the exponential growth. So the more steps you want to plan, then the bigger the search space becomes. And even maybe the number of the choices, right, could be just a 10 or even smaller. But if you make it say 10 steps each time you think, right, then the number will be huge. So what we're going to spend a lot of time in this class is how to do the search in this huge search space. Okay, we're not going to make it very competitive in terms of the essence of intensive calculation. That's not the idea for this class. Many of you, right, were in the USCO class. This one is different. The focus is not find out the best algorithm or data structure to solve the problem. This one is we're going to imagine how do we teach the computers, right, to do it in a more rational way, to exhibit intelligence. Okay, and we're going to do this one in gameplay. So we're going to utilize some of the simple games. For example, right, we can use the chess, even though we're not going to build the capability like the Deep Blue or like AlphaGo, right, to play Go. Rather, we're going to start from simple games, for example, right, the checker, or say Connect Four, right? Everybody knows how to play Connect Four. So we're going to apply the techniques to search maybe the best move using what you have, your own expertise system, and also with the power of your computer. And for these, we're going to, again, skip for these constrained satisfaction problems, graphical models for the search space logic. This is, as I mentioned, right, first order logic, so that you can build the system to represent the problem. There's a huge chunk of AI now using the Markov decision process. So you're going to have the probabilistic model. So each move, right, there's no definite. So this one is the best. Sometimes maybe we don't have such a clear idea how to define the best move. Maybe it's modeled by probability. So maybe taking this one has the highest chance within the model. So we're going to do a lot of the statistics. And also the most recent model, right, the deep learning, the reinforced learning. So we have a lot more to cover. But anyway, in this class, we're going to do basically the search strategies in gameplay. Okay. The goals for this class, we're going to help students get interested in artificial intelligence. So we're going to focus on the searching strategies and ask students to implement the techniques in simple games. And also, more importantly, we're going to ask students to participate regular contests in class. And you might ask, right, you said we're not going to do the contests like the USCO Computing Olympiad or even the ACSL, the contest within American Computer Science League. This one is contests in class. So kind of similar to the debate class you might have. Okay, we're going to talk about in a moment, right, how that contest would look like. the contents that we're going to cover. The order does not have to be the same way here. We're going to talk about common data structures and also the algorithms associated with them. So here we're not going to have creative data structures, only the common data structures that we're going to use. Again, the efficiency of our code is not the main focus as use code. Okay, we're going to do the uninformed search strategies and also informed strategies. So here we're going to say every move probably would have the same weight. You don't know. Say when you play chess, right? Maybe queen should have more weight than other pieces. But if you don't apply the weight, then we also have the uninformed search strategies. But you can also have the informed search strategies. So we're going to talk about these to apply them in the board games. These are the topics, possible games that we're going to use. So for example, right, Connect 4, Othello, Hanoi Tower. So you're going to see the infrastructure has been built. And you're going to just implement the strategy so that give me the board configuration. What is your move? If you play, say, player 1, right? What's your move there? And the same configuration if you play 2, right? What's your move? Or if it's like the Hanoi Tower, right? Here there are no 2 players, just 1 player. What's your move? So the games actually would be well defined. Sometimes we may change the game a little bit, so you don't make just copy the code from other places. So it's well defined. You can say, given the configuration, what's your move? Okay, so the infrastructure would be built, and you can just write code on top of that. The second semester, we're going to make this one 2 semesters. The techniques, concepts, we're going to cover heuristic functions. This one is actually very useful for us to better perform the searching. And also the search space, what's in general, right, very big. So how do you prune the search space? So you're going to cut a lot of the branches so that the size of the search space could be reduced. So the smaller the search space, right, the better for you to do the search. And also we're going to talk about local search and also optimization. And a very important technique in AI for game playing is the min-max tree. And we're going to do this one in the adversary search. Okay, these would be a little bit more complicated than the ideas, concepts that we're going to introduce in semester 1. So anyway, you don't have to use them. But if you can, your AI player would be more powerful. Okay, so again, some of the questions we're going to talk about, like the Sudoku, right, 2048, or like the Pac-Man. Again, the games we may change. Actually, if a student writes says, okay, we have this famous game, can we do this one? Yes, we can do this. But of course, I need to spend more time to make sure the infrastructure is ready. Here are some specifics for this class. We're going to mainly use Python for coding. And if you have prior experience with, say, Java or C++, that's fine. Okay, as I mentioned, right, we're going to make sure the infrastructure is ready, is running. And we just need to put your code, say, give you this configuration for the board, right? How many pieces have been added by player 1, by player 2, or for, say, Pac-Man, right? You have the dots, you have the ghosts, right? And your current position, what's your move. So the input is very specific, right? Determined. And your output is also very well specified. Where do you want to put the piece, or where do you want to go? So coding is mainly by Python. And if you do others, right, that's fine too. And we're going to mainly, right, talk about the search strategies. In this normally gigantic search space, which move you're going to choose to pick. Okay, so you're going to do a lot of study. And also you're going to prepare a lot before class, because you have to write a code, if not all, most of the code before class. And in class, we're going to have the competition. So if it is single player, right, we're going to say, show your code. We're going to ask you submit a code, and we'll just hook it up. That should be easy, right? Basically, mainly we'll just implement a function. So we just say add your code to the infrastructure, and we're going to see how that goes. So if it is a two-player game, so we're going to ask two students to be player one and player two, and we're going to let the two programs to compete. And we're going to switch the role, right? Maybe Jack will start player one first, and John will be player two. And after one round, they're going to say, John, you're going to be player one, and Jack, you're going to be player two. So this is very similar to the debate class. You have the option to do one person presentation. And we're going to have the score, right? For example, the Pac-Man, how many points you're going to score at the end before game over. For two players, right, that's also easy, right? Whoever wins would be, the winner, get the points. Okay, so we hope this class should be easier than the USCO class. So many students thought, right, the designing games development would be fun, and adding the AI player hopefully will be more interesting. And this one does not give you the high pressure, as many students gave us the feedback, right? USCO is getting so hard, especially after I have the promotion to silver level, to gold level, right? It's so hard. Yes, it is hard. But this one is a completely different branch. So you're not going to have the creative algorithms, so that you have to finish the calculation within, say, 2 seconds or 4 seconds for each test case. It's not that case. So you're going to study the games, make sure you know the rules, and then build your system so that you're going to find out the best move within the capacity of your computers. Well, actually, once you submit a code, right, it will be all run on my computer. So that will make sure everybody has the same resources. So sometimes, right, maybe your computer is faster and John's computer is slower, so you have advantage. So here, that's not the case. Everybody will submit code to me. So both AI programs or AI players, right, will run on the same computer. Right, so for this one, we're going to make sure everybody should have this prerequisite. So prior experience in programming. So if you have learned Java, that's fine. If you learned C++, that's fine. You have had Python, that's the best, because Python would be the main language in this class. And our infrastructure would also be built using Python. But as I said, if you have Java and C++ experience, that's fine. Your code still would be accepted. I would just port it or add it to the infrastructure and let it run. All right, so here's one example of having two players. So here is a general board for Connect 4. Two players, right? So for example, Jack is playing player 1, John is player 2. So Jack will start, say, red, and Jack will choose one column to place a piece in the board here. And John's turn, right? John will also find out a place. So as if two human players are doing this one, but now once you submit your code, then you just sit there, just watch. And then the infrastructure, right? I'm going to make sure the platform is running. So we're going to have the pause, right? So player 1 has one piece, player 2 has piece. At the end, we're going to see whether there's a winner for each game. And we're going to switch the player 1, player 2. So hopefully, right, like the debate class, we're going to see who is the winner. And we can do this one for multiple pairs. Okay, as I said, right, we can, since we're developing the games, so we can make small changes so that actually, right, for Connect 4, most of the AI classes in universities, in college, would have such a problem. So actually, we know at each move, right, the best move, at each configuration, you can find out the best move for player 1 or for player 2. And actually, if both players are doing optimal moves, then we know, right, after how many steps player 1 will win, or after how many steps, right, player 2 will win. So to avoid the copy paste, right, we're going to change the board slightly. For example, we're going to say maybe for this time, right, this piece, you cannot add a piece there, and we're going to assume, right, there is a piece already here. You can always treat this one as yours, or player 2 can also use it to treat this one as his or hers. So we're going to change this configuration slightly. This actually would be kind of easy for us to do, and you cannot get the code from the search and find out the best AI player, right, for Connect 4, because we're going to change it. Actually, we're not going to do any other framework. Remember, right, this is a simple, maybe the early stage of the AI class. So we're going to just, build the framework from scratch. So don't worry about that one. So each one of you, right, just what you need to do is just write the function. As I mentioned, right, giving you the configuration of the board. As player 1, what's your move? And as player 2, right, what's your move? Okay, so that's for 2 players. And if you do 1 player like this one, this is actually, again, similar to the Pac-Man. Well, here we don't have 4 ghosts, we only have 2. And then the maze can be arbitrary. So each time we can change the maze, and we can change the number of the ghosts and change, right, the dots. Still, every time, right, once you submit your code, it will make a move. So to eat the dots, and hopefully sometimes eat the ghosts. And we're going to have the rules, right? How many points you gain after eat dot, how many points you eat a power pellet. Again, we can change the rules of the game so that you have to write the code by yourself, not just by copy paste from code that somebody else has developed. And for each one, right, that's again easy to find the score, right? We're going to let your program run, and before game over, right, see the at game over, see what's the score, and whoever has the highest score would be the winner of the contest in class. So this is what we had in mind actually several years ago when we had the GUI part in our introduction to computer programming. We thought this one, but then we removed this part, even though it was very interesting, very inspiring to many students, from game playing to game development, and also add the AI part. Because the use code that we focused, we focused completely in the past several seasons. Now, since the AI, due to the release of ChatGPT, a lot of students and parents expressed idea, the interest, right? Can you offer such a class? So we said, yeah, we can do this one. Before it was just using Java. Again, as we mentioned earlier, right? At Momentum, we do not have our opinion on languages we use. For general purpose language, as long as you use it in school, then you can use it at Momentum. So the same thing here for this introduction to AI class. If you have experience in Java, that's great. Keep using Java. If you have used the C++, you are fluent, then keep using it. And also, right, if you are fluent at Python, then you can keep using Python. And we're going to mainly build our framework, the infrastructure, using Python. And hopefully this class will be useful for your continuation, because in many universities, now the introduction to AI class also would be using Python. I did a research for almost all such classes in universities. Without exception, to the best of my knowledge, all of them are using Python. Well, because Python is easy to get started, and also it is the program is shorter. Even though the performance, right, for using Python, right, would be slower than Java or C++, but for questions like this, speed is not an issue. Let me just say one more word about this one here. We did mention, right, the search space is huge. Even in problems like this one, gameplay, right? At each move, there are so many choices. Next move, right? Again, a lot of choices. So in general, this search space is huge, exponential growth. So if you say, if I can speed up the performance of my algorithm, my program, right, by a factor of 2, it does not help. If it was infinity, divided by 2 still is infinity. That means you cannot finish the calculation or search the space complete, right? Enumerate all the possibilities in the search space. It's impossible to finish. So here does not make any difference which language you use. So C++ may be faster than Java. Java is faster than Python. Well, maybe a factor of 2 or 3, but that still does not make any difference when you try to reduce the search space or make it very fast. Okay, so our idea is actually try to read through the search space, right? Maybe at the first time, I know, right? Even though if like naively there are 10 choices, but I know there was only one choice would be the best. So I don't have to search the other 9 branches, just to focus on this one branch. Later, right? For all the subsequent moves in the other 9 branches, right? I don't have to consider at all. So here you're going to reduce the search space size, right, by 90%. So that's what we want to do, to prune up, reduce the size of the search space. And if you can reduce the size, the earlier, the better. So that's what we want to do in this class. So build the AI player by first realizing, defining, excuse me, defining the search space, and then try to use your system of expertise, try to improve, to reduce the size of the space. All right, you can get the information at Momentum website. So go to momentumlearning.org and choose here 2023 4 online and this AI class, and you would get the information there. And this one would be offered on Monday evenings from 6 to 8 p.m. Central Time. All right. Again, here is the contact of our front desk at Momentum Learning. You can either send us email or send us course at this number, and our front desk will be very happy to answer any question that you might have. All right. I'll stop here and answer any question that you might have for this class, Introduction to Artificial Intelligence.